Okay folks, so the second video I wanted to work through was again from exercise 6J. This is question number 5. So the diagram shows a cylindrical heap of gravel. The slant height of the heap is 8 meters. The radius of the base is x meters and the height is h meters. A, we need to express x in terms of h. B, construct a function which expresses V, the volume of the heap in meters cubed in terms of H. C, use a CAS calculator to help draw the graph of V against H. D, state the domain for the function. E, find the value of V when H equals 4. F, find the values for H for which V equals 150. And G, find the maximum volume of the cone and the corresponding H value. So as I've mentioned previously, read and reread the question. We really want to try and understand what is happening in the question and think about what maths we might be able to bring to it before we go too far. So the first thing, I've got a question that I have to express x in terms of h. So I've got to come up with some formula that links x and h together. Then I've got to construct a function which expresses V in terms of H. So that's telling me I've got to come up with an equation, a function equation, that has V in terms of H. So it's going to be something like V equals something blah, 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 H. We get to use our CAS calculator to draw the graph. And again, we're going to be using V against H. We have to state the domain. So we'll talk a little bit more about the domain as we go through that part of the question. We haven't done a lot on domain yet, but a little bit. Find the value of V when H equals 4, so we're solving or substituting. Find the values of H when V equals 150, so we're substituting and solving. And then we need to find the maximum volume. So if we look at the graph, we can find the highest point. Okay, so let's actually start working through this problem. I've got the diagram already there for me, and it's already a three-dimensional diagram, so I don't need to do too much. But I'm going to do one thing, and I'm going to separate out this right angle triangle that I can see in the problem, because in the previous example, we took the two-dimensional diagram and turned it into a 3D diagram. In this case, we're going to do the opposite. We're going to take the 3D diagram and turn it into a two-dimensional diagram. That way we've sort of got both elements that link together. And we can think about, this can help us think about what we might be able to put together. All right? Okay, so let's do part A. Again, we've reread the question and I've drawn a diagram to help. And when I say express x in terms of h, now I can get a little bit muddled up with my 3D diagram because when I think 3D diagram, I automatically think 3D has to do with the volume. Now in this first question, part A, it doesn't mention anything about the volume. It just wants x and h. So in this case, it makes more sense to work with the two-dimensional diagram. And when I've separated it, I'm hoping that you recognise that that's a right angle triangle. And because it's a right angle triangle, we can use Pythagoras' rule. So this is where we have to be strong in all of those elements of maths that we've done already. So Pythagoras' rule says that a squared plus b squared equals c squared. In this case, that gives me h squared plus x squared equals 8 squared. And you can see I've really quickly created an equation that has an x and a h in it. So now it says we have to express x in terms of h. That means I've got to get x by itself and then h separate. So let's first move the h squared to the other side of the equal sign. And then I am going to take the square root, which is 8 squared minus h squared. And like always, I have a plus or a minus value here. But this is where the application problems really take form. When we're doing just symbolic maths and we're working just with numbers, we have to consider that there's both a plus and a minus answer. But in reality, can this length x ever be a negative number? No, it can't. Because it's a length, it must be the positive value. So because of this reason, we can actually ignore the minus and just do the square root of 8 squared minus h squared. And if you wanted, you could make 8 squared equals 64 and make that look a little bit simpler. I'm happy with it as it is. All right, part B. Part B says construct a function, expresses v in terms of h. So now it wants the volume. It starts talking about the volume, so I've got to start thinking about the three-dimensional version here. And what I need to start doing first is say to myself, well, how do I find the volume of a cone? And the volume of a cone must have good math strength. I know is 1/3 pi r squared h. Okay, so we've got 1/3 pi r squared h. If you need to look that up, then you jump on the internet and you do a search for how do I find the volume of a cone, and it will tell you. In our case, we have that pi is always pi, but r is actually equal to x. So the radius of my cone is x, and h is just h. And then finally, it tells me it wants the volume in terms of h. So I don't want to have any x's in here. I want to have just h's. So what I have to do now is I have to substitute in that first part, or part A of this problem. I have to replace the x with this expression. So my volume equation is going to become 1/3 times pi. I'm just going to put the times sign in here, times the square root of 8 squared minus h squared, all squared, times by h. And then I can do some tidying up. Now, squareds and square roots are opposite functions, so that just becomes 8 squared minus h squared times h. And we can start putting some of these bits together. I could just type it into the calculator and see what happens, but I'm going to keep working by hand at the moment. The first thing I'm going to do is I'm going to put the pi on top of the 3. I'm going to write the time sign. I'm going to bring that h to the front of the expression, and then I'm going to square the 8, and I get this as my rule. So I could stop here if I wanted, but just to help you see that it's a cubic, I'm actually going to go a little bit further and make that times 64h minus h cubed. And I can write my expression like that if you like. Doesn't really matter. I could keep expanding if I wanted. I could have stopped up the top here, but don't stop here. Don't stop at this line, but you could stop at any one of these points here. Nice. Let's do part C. Part C said, use CAS calculator to help draw the graph of V against H. All right, so let's jump onto my CAS calculator. I need to add a graph screen. And with the calculator, notice up the top, it's got f1 of x. My expression was V and my variable was H. When I'm using the CAS calculator, my CAS calculator doesn't know V and it doesn't know H, it knows f1 of x. So I'm going to actually replace the H's with the x for the sake of entering it onto the calculator. So I've got a fraction of pi over 3 times the x value times by 64 minus x squared. Hit enter, And all of a sudden I've got this graph that looks horrible. I've got 3 lines, I don't really know what's going on. So it looks a little bit different on the iPad, but if I press the menu button and then zoom, and you can try, I always try a zoom fit. That's a pretty quick one to see what's going on. And then we go from there. So what we end up with is this is a graph that shows me what the volume is equal to when I have the height. So I'll just take a screenshot of that, and I'll go back to my maths page here, and I'll add from my photo library. Here you go, insert one photo, and I can play around with this a little bit. I'm going to crop because I don't need that top bit, and I just need to go a little bit wider there. Beautiful. So here's my graph, and that's really nice that I can stick it straight in my notes like that. But let's interpret this before we move on. Let's actually stop, and rather than saying, hey, I've just got a graph, let's think about what it actually means. This y isn't y, it's actually the volume, and this x isn't x, it's actually the height. So what it's saying is this point here is telling me that the height equals 0 and the volume equals 0. This point here is telling me that when the height equals 8, the volume equals 0 again. Over here, this is basically saying the volume is negative because it's below the x-axis, but also that the height is negative. So just think about that as we move forwards. Can I have a negative volume? Probably not. And then we've got some point in the middle here, not exactly sure where it is, but some point here where we're going to have the maximum volume. So the volume hits its maximum value when I'm adjusting the height. Please don't forget that even though my equation only had h for height, we related the height to the x value. So when I'm adjusting the height here, I would be by default also adjusting the x value. And so we're either having a sort of mid-size cone, or we might have a really wide and low cone, or we might have a really tall and skinny cone. So all of these are going to give me different heights and different volumes. Okay, so that's what's going on in this problem. So that's what we've created here, and this is what my graph's trying to represent. Okay. Okay, so there's my graph. We probably should put some axis intercepts on there. So I'm going to just say that that's 8 and 0. I can see that by just the labels, and that's 0, 0. I don't know what this maximum point is. It's really useful to put this on a graph. I'm going to say that's -8 and 0, but let's go back and find out what that maximum value is. So let's have a look at our calculator. I can press menu, and then in menu you can use trace, graph trace, and then you can just arrow across. And you can kind of find that maximum point here. Now on your calculator, it should, when you hit that maximum point, it'll actually jump to it. And down the bottom it tells me that the coordinates for that maximum is when h, the height, is 4.62 and the volume is 206. So 4.62 and 206. 4.62, 206. All right, that's a pretty good graph. I'm going to leave it like that for now, and I'm going to move on. Part D. Part D, state the domain for this function. So the domain has to links with what I was talking about for these points here. In my graph, I can't have a negative volume. So I can't have a negative volume. I also can't have a negative height. So that means the only part of my graph that I need to include is the parts where both the height and the volume are positive. Only include, sorry, I'm trying to write and think at the same time, only include when the height and volume is positive. So in this case, I'm going to say that my domain is for h greater than or equal to 0 and less than or equal to 8. So I set my domain between those two values because if the height is not between 0 and 8, then it's not physically possible to have a cone because I can't have a negative height and I can't have a negative volume. And this is how I write my answer with those inequality signs. All right, part E. So part E tells me find the value of V when h equals 4. So very quickly, we had our formula from before, which was pi on 3 times h, 64 minus h squared, and we want to find V when h equals 4. So this is a simple substitution problem. Whenever you see something like h equals 4, your first step should always be just to substitute it in. And once you've substituted it in, have a look and think about what's actually going on. All right, so that's really simple. So V equals pi on 3 times by 4 times by 64 minus 4 squared. So this becomes 4 pi on 3 times by, so that's just my fraction skills. Again, we need to have good skills of our basic maths to move through this quickly. 64 take 16 is 48. So I can have 4 pi times 48 over 3. Now I deliberately haven't times the 4 and the 48 because I know that 48 divided by 3 equals 16. So I can actually just put these two bits together and rewrite the expression as 4 pi times 16. And then I know 4 times 16 is 64. So there's my answer. The volume is 64 pi units squared. Now in my problem at the very beginning, it tells me that it was in metres. So I can say it's 64 pi metres squared. And then I can use my calculator to do 64 times pi and get an approximate answer. So 201.06 metres squared. 201.06, which is approximately 201.06 metres squared. Okay, these little tricks with the 48 and the 3, those come with practice. The more practice you have doing things by hand, the quicker you can do that. All right, next part. F, find the values of h for which V equals 150. So as I mentioned before, it tells us V equals 150. So let's not waste any time. Let's straight away, my pencil stopped working, let's straight away substitute in V equals 150 and see what happens. Oh, this going to be really bad if my pencil stops working in the middle of the video. I'll just give it a moment. So V has to equal 150. If I substitute V equals 150 into this equation, no, I'm dead. I'm going to end up with something that looks like 150 equals, and then we had pi over 3 times h. Now we can use x again if we want. It's just easier on the calculator to use x, times bracket 64 minus x squared, close the bracket. So that's my expression. Now if I just hit enter on that, I just get that. But it wanted me to find the values of x. So here we've got an expression that's got x's in it and an equals sign. All I have to do is solve. So I can use my calculator to actually do that solving for me. And here's the expression that I have to solve. And I want to find out what x is. Hit enter. And you can see I get 3 answers. So I've got x equals negative 8.94. I have x equals 2.47, or 2.48 if I round off, and x equals 6.47. So in that problem, again, I'm just going to take a screenshot of this and come back to my problem, and my Notability has completely frozen. I would only take, because the video is nearly over, I'll just finish off on the calculator screen. What I would do is I would ignore the x equals negative 8.9. And the reason why is because x represents the height here. And as we said before, the height can't be negative. So given that we said that my height value has to be between 0 and 8, the only 2 answers I need to write down are the 2.475 and the 6.47. All right, and then I would just use my calculator and they would be my 2 answers. X equals 2.475 and x equals 6.47. Okay, so I'm actually going to stop there because the screen's frozen and I can't do any more. Part G, I can't remember what part G was, but I'll have a look at that one in class. All right.